today I'm going to show you how to do a WooDDAM survey of this particular jam. This will be an initial survey. So I'm looking at the jam from upstream. First thing I'm going to do is start taking some pictures because I'm going to move around this jam. So I've got my smartphone here. I'm going to shoot in wide angle, and what I'm shooting for are pictures from all angles of this jam. So I'm going to take one here. I might move around to the side. And the idea with these pictures is to ensure that you can see all sides of the jam, because when you come back to resurvey a jam, it's really helpful to look at these pictures taken during an initial survey. It's really helpful to try and kind of relocate yourself in the same position when you do a resurvey. Take these pictures again, then you can compare them either in the field on a phone or a tablet or in the office, and you can really clearly see how a jam has changed from year to year. I think that's one of the coolest things about doing a WooDDAM survey, is that you get to notice all the different ways that wood jams change through time. All right, so I've got some pictures, at least from every angle in the channel. I'll move up on top of the jam in a sec here and take some more pictures, but for now I'm going to start recording data. So hopefully you can see my phone screen. This is the WooDDAM database. I've opened it in Microsoft Excel. The first thing I'll fill out just while I'm in the field is the jam ID. There are some other variables that I'll fill out back in the office, like which state I'm in, which river it's on, the survey number, stuff like that. I find it easiest in the field to just write down. I'm going to call this jam Cedar 100. This is on the Cedar River in Washington. So I'm going to call it Cedar 100. I'm going to give it a descriptive location. So I'm going to say right bank near middle of Cedar Rapids Reach. That's where I am now. Just downstream of another large ELJ. The other large ELJ, you can kind of see it. It's right over there. So that helps me if I'm having a hard time when I come back here in a year or 2 years relocating this jam. I'll also have a GPS coordinate, but it's good to have some redundancy. Now, this is a really recognizable jam, so I'm not too worried about relocating it. But say I was working on something, you know, over in those bushes, I would want to have a good descriptive location so that I'm making sure when I resurvey the jam that it's the same jam that I initially surveyed. It's really a bummer if you go out and you can't find the jam that you intended to survey. So next few variables, latitude and longitude. I'm going to fill those out back in the office. But first, I'm going to use this app. This is CalTopo. You can use any GPS app. I'm going to find my location, and I'm just going to take a waypoint real quick. Right now I've got some imagery loaded up, which is kind of nice. It makes it easy for me to see that's the jam I'm surveying. You can see I've already put a waypoint on it, but I'm going to put another waypoint on it for this demo survey and call it Cedar 100. Done. And that'll let me find the latitude and longitude and fill that out back in the office. These next 5 variables are all about the flow regime of this river. I'm going to fill these out in the field right now to talk through them, but these are easiest to fill out back in the office, especially when you're looking at say a hydrograph or some record of the flow on the river you're surveying. So first one, perennial. Does the stream flow year-round? This is the Cedar River. It totally does. Is it flashy? This river is in western Washington. It gets high flows mainly from intense rain events, and when it does get a high flow, it tends to come up pretty quickly, even though it's dam controlled. So yes, it can be flashy. Does it have sustained peaks? Yes. Oftentimes that's because of the flow regulation. They will hold it at a relatively high flow for a long period of time sometimes. Does it have ice jams? So does it have accumulations of ice that kind of clump together? No, definitely not. It does not get that cold here. And then, are the flows on this stream melt driven? By and large on the Cedar River, especially this far down in the basin, they're not. There's not much of a spring snowmelt peak here. All right, the next few variables are describing the channel geometry. So this is the channel that this jam rests in. And to fill out these variables, I'm going to need another tool. This is my TruePulse 360 laser rangefinder. And I'm going to use this to survey the channel a little bit, just measuring some basic characteristics about this channel: bankful width, depth, and slope, channel bed slope. So these can be a little confusing in some rivers. What I'm trying to do here is identify the bank full, the point at which flow starts to go over the banks and onto the floodplain. So I'm going to stand here to do that. On this side, what we're looking at is a big terrace, but that's clearly the bank of this river, that scalloped and scoured area over there. That's the right bank. If I turn over here to the left bank, this we're looking at floodplain. So this is a really easy to identify floodplain. You can see this is the channel. As I'm tracing this up, you can see the bank, the steep area next to the channel, and then you can see an abrupt transition in slope where it just completely flattens off. That's the floodplain. There's different vegetation up there. You can see these cottonwood and alder trees, as well as some shrubs and blackberry growing up there. That stuff does not grow in the channel very often. You can see the top of this bar here. This is in-channel surface. You wouldn't see a lot of vegetation growing on this. And even the vegetated bars in this channel, which you can see over there, tend to just have like willow and grass and stuff like that. Really, you don't start to see trees until you get up on the floodplain. So now that I've identified the floodplain, I'm going to walk up on this bar to get a little bit better view. I'm going to use my laser to measure the channel bankful width. And I want to measure this width just upstream of the jam because I want to get the hydraulic conditions that are actually influencing this jam. So I'm going to measure from right about over there, from the kind of vertical part of that bank, all the way over to the top of this bank, the top where it transitions from bank onto the floodplain. So I'll do that now. And I get a value of 66.2 meters. I'm going to input that for bankful width, 66.2. Bankful depth here, I'm going to measure again from the floodplain. So that's the bankful stage, or the bankful elevation is where bank turns into floodplain. So the elevation right at that flat surface that you can see over there. So the deepest part of the channel here is right next to that jam. I've already, before taking this video, I've already measured how deep it is over there. It's about 1.6 meters. So all I'm going to do to complete this measurement, I know it's 1.6 meters from the deepest part of the channel bed up to the water surface. And the water surface is not quite flat in here, but it's close enough to flat, at least given the kind of resolution at which I'm measuring. So I'm just going to measure from the water surface, right where it hits the bank there, to the top of the floodplain. And I get a vertical distance of 1.7 meters. So let's see here. Bankful depth, 3.3 meters. All right, so 3.3 meters bankful depth, about 66 meters bankful width. And that just leaves the last variable, which is slope. Slope, I want to measure the slope of the channel around the jam. So I'm going to measure from pretty far upstream of this jam in that riffle right there. You can see where the water gets really steep. You start to see a lot of white water there. That's sort of a riffle or a steepened zone. I'm going to measure from that Pretty far down on this left bank. Ideally you'd go from, you know, one riffle to another. This channel isn't quite uniform enough to do something like that, but the way I'm going to do this is I'm going to measure some point on the bank over there. So I'm going to shoot my laser out there. Okay, and then keeping my laser in place, I'm going to turn around and I'm going to shoot another point again on the left bank, right where the water hits the bank. And I get a slope of, let's see, 0.6%, which is about what I'd expect for this reach. So under slope percent, I'm going to put 0.6. Done. And so what I just did, I measured the water surface slope. You can also measure the channel bed slope. Generally, if you're measuring the channel bed slope, you want to measure over a long area if you can. You want to get an average slope for the reach. All right, class size in this reach, what I'm looking for is the median bed surface grain size. So what I'm looking at right here, this is a bunch of cobble material. One easy way to do this, one easy way to estimate this variable, because all you're trying to do is differentiate between sand, gravel, cobble, and boulder. Unless you're in a bedrock stream, but if you're in a bedrock stream, well, you should be able to tell. It's just solid bedrock. There are no, you know, little clasts on the bed. So in this case, I've walked around in there a bunch. I know that most of that is cobble. There's a little bit of gravel here. Most of that channel is cobble, and all this area is cobble. The way I can tell it's cobble, generally cobbles are about a tennis ball size or larger. So I use that kind of mental image of a tennis ball and think, okay, are these clasts kind of on average larger than a tennis ball? They are, so therefore they're likely cobbles. So under class size, I'm going to put C for cobble. I'll zoom in here a little bit. There we go. Hopefully you can see that. Bed form. So this is a bed form classification. In this case, we're looking at a pretty classic pool riffle reach. The way I can tell is that there are these steep zones like this. That's a riffle. And then the water surface gets a lot flatter in these pools, and the channel tends to get a little bit deeper, at least at low flow. So for bed form, I'm going to put PR, pool riffle. Plan form, really what we're looking for here is two things. One, does the channel have multiple threads in this reach? A thread is a bankfull channel. So if there were multiple threads across the valley bottom, we would see maybe one channel like this, and then a floodplain. This is not a floodplain, but you'd see floodplain here and then another channel. In this case, we don't have that. We have a single thread channel, which means that there's one bankfull channel going down this valley bottom. It's not split in half or in thirds or whatever. So it's a single thread channel. And then the next thing I'm looking for is sinuosity. Does it have a decently sinuous planform where it's meandering? In this reach, so I'll also look here. One nice thing about this Excel spreadsheet, in case you're wondering, it has little comments on all of the variables. I'll try to show this, that define each variable, which is really nice, because even I forget some of these things, and I pretty much came up with this. So plan form, I'm supposed to record it as straight if one channel, so single thread, and the sinuosity is about less than 1.5. Meandering if it's one channel and sinuosity is greater than 1.5. And there's evidence of migration, so point bars and cut banks. Anastomosing if there are multiple channels and vegetated islands. Don't really have that right here, maybe a little bit upstream, but not right here. And then braided if there are multiple channels and non or sparsely vegetated islands. This almost could be a braided channel. I'm almost leaning towards that, but I don't think that this condition is all that typical. Most of the places along this reach, you have decent curvature. There are things like point bars here, and then migrating cut banks like that left bank. So I'm going to call this a meandering reach. So the plan form here that I'll record, I'll just record M for meandering. Next variable, isolated. This is just asking if the jam is completely alone in its reach. In this case, it's clearly not isolated. There's a jam there. That's the one I'm surveying. There's another jam. There's another jam. There's probably a jam. There's a jam. There's a jam. There's a jam. There's jams all over the place. So, nope, not isolated. So I'm going to record a 0 for that. I use 0 and 1 for no and yes. So that's a nice, easy way to record it. Side channel. Is this in a side channel? And the definition of that, a channel with approximately less than half of the cross-sectional area at bankful flow of the main channel. Well, there can't really be a side channel if it's a single thread channel like this one, or if it's a single thread planform. So no, can't be in a side channel. Is there a floodplain present? Well, yeah, I was just surveying to a floodplain, so there's totally a floodplain present. Yes. Is the reach confined? Okay, this is an interesting one. So confinement is, yes, it is confined if the wetted width at 2 times the bankful stage is less than 1.5 times the bankful width. Okay, so that sounds a little complicated, but if we think it through, it makes a lot of sense. Basically, I go to bankful stage, and I know that my bankful depth is 3.3 meters, right? So if I tack on 3.3 meters to that bankful elevation, the top of that floodplain, if I add 3.3 meters to that, is the wetted width, so the width if water was actually flowing that high, which would be a pretty big flood, is the wetted width 1.5 times the bankful width or more? Yes, it totally is. You might not be able to see this, but that floodplain just kind of goes on like that for quite a long time. I also know that that terrace is probably not 3.3 meters above that floodplain over there. So if I go above that terrace, the flow spreads out dramatically. This is not a confined reach. A confined reach is one where as the flow increases, as the discharge increases, the depth tends to just increase and increase and increase, kind of like a canyon. Whereas an unconfined reach, flow can spread out across the floodplain, and even if you increase the discharge a lot, the stage, the elevation that the water is at, doesn't get that much higher. All right, so for confined, I'm gonna record no. Okay, these next ones are very simple. Does it touch the channel bed? Yes, very clearly does. Does it touch the bank? It says touch bank. Yes, it definitely does. It's literally buried into the bank. It was built that way. Touch floodplain. Does it touch a floodplain surface? Remember, that surface up there is a terrace. So key pieces in this jam do not touch the floodplain. Do pieces in this jam touch the valley wall? That's the hill slope beyond the floodplain. Oh, let's see what this says. So yes, if any key pieces of the jam contact the valley wall surface, including terraces and objects fixed to the valley wall. Well, so if there was a key piece in this jam, a piece that was structurally integral to the jam, that reached up on that terrace and touched it, that would be like touching the valley wall. For now though, it's only touching the bank. So I'm gonna say, no, it does not touch the valley wall. Does it touch an outer bend? Basically, in a meandering channel, there's almost always an outer bend, which looks like this, so like that thing, and an inner bend, which looks more like this. This jam is in a really tightly sinuous part of the bank. In this case, it is touching an outer bend. So I'm gonna say yes. Is it touching an inner bend? You know, to some degree it is. It forms a point. But I'm going to say broadly what it's touching is an outer bend, and I'm going to say no, it's not touching an inner bend. Does it occupy the thalweg of the channel? Well, this jam actually creates the thalweg of the channel because flow velocity gets so high right next to it. So yes, this jam is definitely has pieces sticking into the thalweg. So I'm going to say yes. Is it channel spanning? Well, if it was channel spanning, I'd have to cross all the way across this channel. So definitely not channel spanning. Is it dominantly parallel to flow? Is the bulk of the jam parallel to the flow direction? Well, flow direction's kind of that way, but by and large, I'm pretty sure this jam's kind of longer in this direction than it is in that direction. So I'm gonna say no, it's not parallel to flow. This next one, does it have key pieces over 15 degrees? All right, so there are definitely some pieces in this jam that are sitting at an angle above 15 degrees. 15 degrees is probably like about like that. And there are some pilings in this jam that are just like dead vertical. So they are clearly over 15 degrees, but are they key pieces? Yes, they totally are. So a key piece is just any piece that holds up other large wood in the jam. So in this jam, because it's an ELJ, these large pilings were driven down into the bed, excuse me, and used as key pieces as this jam was being constructed. So this one definitely has key pieces over 15 degrees. All right, what's its obstruction index? Obstruction index is pretty easy for this one. One of the questions you can ask yourself for obstruction index is, do you see light coming through the jam when you look into it? No, not at all. This is a really densely packed jam. Not just because of the large wood, but all of that fine wood kind of peppered around the jam. So obstruction index, definitely a 3. And the definitions of those, 3 is basically you can't see light coming through the jam. 2 is kind of like most wood jams, you can see a little bit of light coming through, but it would definitely obstruct flow to some degree. And then 1 is a jam that's just extremely porous, like a few logs loosely touching each other. So this one's definitely a 3. Morph impact. Does this jam have a morphologic impact? So does it impact the shape of the channel? It definitely does. This jam is creating a big scour pool right here. You can see this deep area of the flow. It's probably generating some forced bars down there. Along with this jam upstream, it's creating this huge cut bank. So yeah, totally having a morphologic impact. Is it buried? Yes, this jam extends into that terrace, which is just fill. It was designed to be buried in these pilings. Generally, when you see pilings on an ELJ, they're almost always buried way down in the stream bed. So that's an easy one. Yes. Does it have key pieces above bankful depth? So, yes, it definitely does. These pilings are key pieces. They clearly extend above bankful depth. That's all we need to know. So key above bankful, yes. Does it have fines? So fine wood. This is an indicator that the jam's been around for a while, because fine wood doesn't really get there until water gets up over the jam and deposits floating material on this jam. You can see all those fine sticks and grass. So yes, definitely has fine wood. Is it pinned on an immobile object? You could argue that the pilings are immobile objects, but really what we're thinking about here are not really pieces of wood, but more things like huge boulders, living trees, stuff like that. I'm not seeing anything. Sometimes folks will build ELJs that are kind of pinned up against living trees. That's a really kind of smart way of trying to anchor a jam, is to put it against something that's rooted into the ground. But they didn't do that in this case, so it is not pinned. And then the next variable is the pinning object above bankful? Well, if there's no pinning object, then it can't be above bankful. That's easy. Decay class. There are 5 decay classes. By and large, most jams will fit into decay class 1, 2, or 3. Decay class 1 is like fresh wood, like wood that's just fallen in the stream. Decay class 2 is the vast majority of jams. Jams that have hard sapwood, like you can't, I can't like grab a piece of wood there and just pull it off. There's still bark on that. I've climbed all around this thing. You can see the chain still anchored into these logs. If it were a decay class 3, you would expect to be able to like kick pieces of wood off of those logs. It's definitely not quite there. There are a few pieces, see that top one, that are probably approaching decay class 3. They're starting to rot. but by and large, the key pieces in this jam are decay class 2. So I'm gonna mark it as decay class 2. Is it in situ? Does it have key pieces that fell in from the bank right where the jam is? Like they fell in and have not been moved by the river. This jam does not have any of those, mainly because it was built by humans. All these logs were probably trucked in. So no, it's not in situ. Does it have root wads? Yeah, totally. You can actually see some of these key pieces have root wads. There's one, there's another one buried deeper in the jam. Definitely, there are some key pieces to which other pieces are either resting on, or to which pieces are, in this case, chained to, that have root wads. So yeah, I'm confident that key pieces have root wads here. Is there live wood growing out of the jam? Yeah, actually. There's a willow right now growing out of the downstream side of the jam. That's a good indicator of stability. You don't get vegetation, especially like woody vegetation, growing on a jam if it's only been there for like, you know, a month or two in most cases. This one's been here for quite a long time. It's been quite stable. It does have live wood growing on the jam or adjacent to it, so yes. Do key pieces have multiple trunks? No, not in this case. These are all single trunk trees, so no, it does not have multiple trunks. Anthro, is this an anthropogenic jam? Yeah, totally. What are the indicators of that? Okay, natural jams do not have threaded rod in them. That's a dead giveaway. They don't have cable. They tend not to have vertical pilings. They tend not to have like every single piece cut off at a nice, you know, nice 90-degree angle. Another dead giveaway for anthropogenic jams, they'll oftentimes have like excavator teeth marks. So they move these logs around with excavators that grab onto them and move them around. They tend to leave little marks in the logs. Those marks will wear away through time, and this jam is old enough that I at least can't spot any from here. But a freshly built jam will often have those excavator marks. And if it doesn't have these other things like, you know, chain and threaded rod and all that stuff, those excavator marks are a really good thing to look for. So, anthro, definitely. It is definitely an anthropogenic jam, means made by humans. What is the proportion of key pieces that are anthropogenic, that were placed by humans? So what I'm looking for here are none, some, most, or all of the key pieces. In this case, there's maybe 1 or 2 key pieces that have accumulated, like this one, since the jam was built. So it's not quite all, it's definitely most. I'd say if I had to like just guess a percentage, I'd say probably like 90%. There are a lot of key pieces in this jam because they're all cabled to each other, or sorry, they're all chained to each other. And the vast majority of them were placed by humans. Does it have internal anchoring? Is there something keeping logs in the jam tied to each other? There totally is. It's right there. It's that chain. And also there's threaded rod. So some of these logs are have threaded rod drilled through them, and then they're actually like screwed together. So yes, it has internal anchoring. What I want for this variable is a note of what is the internal anchoring. So I'm gonna say chain, my fingers are getting quite cold, chain and threaded rod. All right, external anchoring. So for this one, is there anything anchoring this jam to other parts of the valley bottom? Like living trees or large boulders. In this case, there's nothing like that. There's some fill on top of this jam, but they didn't, you know, construct this jam to tie into any other features in the valley bottom. So in this case, there is no external anchor. I'm just going to say 0 for that. Ballast. Is there something providing ballast to the jam, holding it down, keeping it from floating away? So common ballast objects are large rocks like riprap. There are large rocks placed throughout the jam. That's the ballast mechanism. So I'm gonna say boulder. So there are big boulders that are ballasting it down. Pilings, does it have vertical or near vertical pilings that act as key pieces? I've already kind of discussed that. Yes, it does. Is it artificially buried? So when this jam was constructed, was there a fill placed on top of it to bury it? Yes, definitely. You can still see that fill up near the top of the jam. So yes, artificially buried. And then these last two, just some notes for the survey. So picture time. I'm gonna go back to my camera app and just real quick look at the time I took these pictures. 13:21 on the 6th of February. So I'm gonna write that down. That helps me figure out which pictures I took of which jam, because I might survey 10, 20 jams in a day. And then I surveyed that on the 6th of February, 2021. Notes, this is where I might put stuff like, you know, if I was doing this survey for another reason, or like if I noticed something about this jam that wasn't going to be included in the database, I might note that here, but in this case I don't really have much to say about it. It's just a big old ELJ sitting around in the middle of Cedar River. To give you another look at this jam, I'm going to walk over. Whoa, a little deep there. I'm going to walk over and climb up on top of it, just because I know this jam pretty well, but for this little tutorial, I want to make sure you have an idea of what I'm describing here. So now you can see the jam from a different angle. Since I'm surveying this jam, I'm going to take some pictures from up here. It's really handy, like I mentioned before, to have pictures from multiple angles. This just helps me when I come back next year to figure out what's changed in this jam. So if I was doing a resurvey of this jam, which I actually did earlier this afternoon, I would look at my pictures that I took during the previous survey of this jam, and I would look for changes that have occurred. So in this case, this year, so over the last winter, this jam accumulated all that stuff. So this big log and all these smaller logs that have racked onto its upstream side. So it's accumulated wood. That's one of the 5 ways that a wood jam can change through time. So I would note that. I would look for any of the variables that I just talked through to see if any of those have changed. From last year to this year, none of those variables did change. So it didn't require a recharacterization, but in resurveying this jam, I took a bunch more pictures of it, wrote down some notes of what has changed, noted that it accumulated wood, recorded the date and time at which I did this resurvey, and that's it. That's all it took to resurvey this jam. It was pretty easy this year, and I can come back next year and the year after and keep looking at this jam, keep surveying it, keep seeing how it changes through time. You know, as these pilings start to rot out more, as people maybe, you know, burn parts of this jam, or as this bank erodes, we might see it start to behave in some unexpected ways. Maybe it'll accumulate more wood. Maybe it'll even lose some wood. Some of these chains are getting pretty loose. You can see that pieces are starting to kind of fall off there. So this thing's not in great shape. But it'll be interesting to see how it changes over the next few years. All right, hope that's been helpful. This has been a tutorial on how to do a WooDDAM survey.